Hi everyone, my name is Darren, and this is the 15-minute version of my YouTube presentation for my final project, which is on using natural language processing to identify arthritic outcomes in doctor's notes. More broadly, the goal of my final project is to use natural language processing in the context of healthcare. Healthcare is sort of a really broad industry with a lot of challenges and a lot of opportunities. One of them is one of the key goals is to make patients have better outcomes. And the areas that I was interested in was in being able to predict arthritic conditions. So arthritis, hopefully none of you have to deal with it, but I've seen it in person. It's a terrible thing. It can really cripple you in the long run. And there are successful treatments for some types of arthritis, but it requires early intervention, usually by a specialist. But usually you don't see it till it's too late. So being able to predict arthritis earlier, before doctors, your general physician can see it, is really important. So my hypothesis is that by using natural language processing on physicians' notes earlier on in the patient's life, we can build a model that can predict with some likelihood that a patient will have arthritis in the future, even if the patient hasn't actively identified it. The dataset that I'm using is the MIMIC3 dataset, which is publicly available for research use using MIT license. It's actually from Beth Israel Deaconess, which is a Boston area hospital group. It's in their, basically their emergency care, or the equivalent of their emergency room departments, for about 40,000 patients over a period of about 11 years. And in particular, I'm looking at the note events table, which contains over 2 million rows of data, which I thought was pretty exciting. And a subset of that are the doctor's manually written notes, specifically the discharge summaries. So let me just show you the MIMIC data set. So the MIMIC data set, MIMIC3 data set, is publicly available for research use. So you can get a certificate from MIT, apply for access, and get granted access, which I did. You'll see here on the left, there's a number of tables covering a lot of healthcare information, a lot of medical information. So there's admissions, charts, events, diagnoses, procedures, labs, ICU stays, note events, which I mentioned. I'm using basic information about the patients, their prescriptions, and so on. Note events I thought was important because, again, I'm interested in using NLP, and the doctor's notes are the richest source of natural language processing potential. So MIMIC3 allows you to download the data in these sort of formats. They have it in the PostgreSQL database. They let you download in these formats that you can basically re-upload. And they have some scripts that allow you to load it into a PostgreSQL database for your own use. It could be local. It can be on any cloud server. I actually experimented with a few different ones just out of curiosity. So I did load it locally. It's kind of slow running. I did play around with it on Azure because I had some free credits there, which worked. But I ended up going with the reliable AWS. So I have an RDS instance here, as you can see. I call it Mimic Test, for lack of a better term. And it's running PostgreSQL. It's a small database, and it has a EBS volume attached to it to store data. So instead of showing you the slides, let me just jump straight into the notebook. So at the top of the notebook, you'll see the necessary imports. Most of these things are pretty standard, so NumPy, Pandas, all the stuff for natural language processing like NLTK, Spacy, Gensum, and then some of the various deep learning libraries that we've used, Keras, sklearn, and so on. Excuse me. In the second cell here, you'll see that I'm using the scicopg2 Python library to connect to the AWS database. Um, the next cell here just makes it for better visibility. And most importantly, what the SciCop G2 library lets you do is write a SQL query, basically in SQL format, and pass that straight um, to the library, to the API, to be handled, to run the SQL query on the database. So see here, this is the query that I first ran, and actually ran a lot of iterations of this one. The first few were just data exploration, so just a bunch of select star from tables just to see what the data looked like, what the columns were, how the different tables are related, what columns I could join on. My initial thought was actually just to look at the node events table and join it with the diagnosis ICD-9 table. And the ICD-9 codes are the the official diagnosis codes for medicine. So if you have any healthcare condition, there's an ICD-9 code for you. And actually, we're on ICD-10 now, but the Mimic3 database is a little bit old, so it uses ICD-9. And actually shrunk down. I stopped that approach, and I still have the join here. In sort of hindsight, I don't need it anymore. But my initial thought was to join ICD-9 and node events, but I realized is that there's a lot of repeat patients, for better or worse, at the emergency room. And these are just discharge summaries, so they're being discharged multiple times. So these aren't, for a really long visit. They might have had a 2-week visit. They came back again and again and again, which is unfortunate, but it happens. So then these sort of match the different ICD-9 codes, but the person has arthritis. So what I did is I just extracted unique notes for unique subjects. And actually, the notes from visit to visit were almost identical. So there's really no loss of data by picking only one of them. And then I have a second SQL query here on the diagnoses table, the diagnosis ICD table, which allow me to pull the ICD-9 codes for the subjects. So you see that there are sort of a many-to-one relationship between the codes and the subjects. So now I have the sort of two tables with the two data frames now in Python with the stuff that I need. The other thing I needed is the list of the ICD-9 codes that I'm interested in, and these are the arthritic conditions. So there's this URL that I went to that shows the ICD-9 codes for arthritis. And show you that really quickly. So you'll see them here. There's a bunch of them. So I extracted these, put them in a list, and then basically created another table, which is the subset of patients that had any one or more of the ICD-9 codes from this list. So that gave me two data frames, one called data from my original query and the other called arthritic patients. And then I merged them. So I had a single column with a Boolean, 1 or 0 value, identifying whether this patient with this set of doctor's notes was arthritic or not at any point in time during this set of data. The next important thing that I have to be honest, I probably spent most of my time figuring out how to download the data, get into the database, and extract it and explore. The next big chunk of time was actually the data cleanup. So you'll see here, I ran a data cleanup on a sample text. And here's a function. What I wanted to do was extract the subset of the discharge summary that could be used for a prediction. So removing any medications that were dead giveaways for arthritis, removing any explicit references to arthritis itself. So this function looked between the two sections of the doctor's notes called history of present illness and medication. Here you'll see my process of running it through on the sample text, and then down here applying it to the my entire data frame of all the data that I had. It's not the prettiest cleanup, but a lot of it was done piecemeal and added on, but it got me what I needed. The next step I had here was to tokenize the text into tokens. And then finally, I decided to go with a bag of words model because I thought that each of the individual words in the doctor's notes are probably important. And to make this work, I created a tag document. So basically what this was splitting the data set into training and testing data sets. I did a split of 0.3 for the test size just because there's by the time I cut down all the data, there was a few thousand discharge summaries left to work with. So I wanted to make sure there's an adequate amount of data for the testing to be, the test data set to be useful. And then the tag document was basically for both the training and testing data sets, tagging them. So there's the set of tokens and then tagging it with whether the patient was arthritic, 1, or not arthritic, 0. So you'll see here one example of the tag document. Here are the words, and the tag here is 0. So this patient happened to not be arthritic. Next you see here is the doc-to-vec model using bag of words, building the vocabulary, training the bag of words model. I did it for 50 epics. I tried different values. Anything over 30 seemed to be good enough. And then finally, I used the bag of words model to train a logistic regression classifier to predict arthritic outcomes. And so you'll see this here. And then using the logistic regression model to predict on the test data set, I got an accuracy of 0.985. So I was a little bit concerned that this was kind of high. So I decided to try out building a Keras model instead to see if I would get a different result. So you see a very similar thing here. So I split out my testing and training data sets here. And then I did a word-to-vec model. So here's labeling the notes again. Basically, same thing. So using label sentence, and then labeling it with basically be train 1, train 0, or test 1, test 0, corresponding to arthritic or non-arthritic for each of the train and test data sets. Building the word-to-vec model. And then what I did for the Keras model was I first used the TF-IDF, the inverse document frequency, to build sort of an average vector and tag that. So you'll see here that I've computed the average TF-IDF score and then made them standard normal. And in here, define the Keras model and then train the Keras model. So the model I've set up uses ReLU activation, RMS prop, and binary cross entropy. So these are the standard ones that we've used a lot. And based on my review of the documentation, I didn't see any reason for changing that. And then since I wanted a binary or classification based on my Boolean sort of arthritic or not condition, I used sigmoid. Softmax would have worked as well. And I trained the Keras model. So basically, we're using these TF-IDF vectors to train the model for prediction. And then you'll see here the prediction accuracy actually got a very similar result, a little bit higher actually, around 99%. And my takeaway from here is not that my model is amazing, but this is more of a constraint of the data set that I'm using. So, keep in mind these are emergency room patients. These are not people seeing arthritis specialists. They're coming in for some other critical condition. So for one of these doctors to have indicated that the patient has a diagnosis for arthritis means that the arthritis must have been identified by the patient or by one of the patient's caregivers, or it must have just been extremely obvious. For example, patients with rheumatoid arthritis will have grossly deformed joints, for example, on their knuckles. Or it could have been in their existing patient history. Um, I think that is much more likely given the data set. So what's encouraging here is that it means that the doctors are taking pretty good notes. I think the arthritic conditions, by the time they're visible in an emergency care setting, are pretty bad, and that they're accurately documenting the diagnoses as well. So I think this model could be still useful for sort of a double check in a similar sort of setting on, hey, we see these notes, but you didn't indicate any arthritic conditions. Are you sure? But probably less useful for early diagnosis of a patient who's maybe younger, not going to the ER for some life-critical condition, but might have really bad arthritis 10 or 20 years in the future and would benefit from some early intervention. I am interested in investigating that type of model, but it would require a more specific arthritic data set, and I hope to be able to do that someday. Lastly, for my data visualization, I thought it'd be interesting just to do a simple word frequency chart for both arthritic patients and the second one for non-arthritic patients. So I've done that here. This is the chart for arthritic patients. And this is the chart for non-arthritic patients. So looking at the top 20 words, there's a lot that are similar, a few differences. But the distribution patterns are notably different. So this one drops quickly, and this one is almost like the inverse, especially in the top 10. Not being a medical professional, I don't know what this means, but I think it's worth investigating, and I hope to learn more about it in the future. Thanks everyone for your time, and take care. Bye.